What is ocean circulation? How does it work, and why is it important? Ocean circulation, also commonly referred to as thermohaline circulation, is the non-stop movement of water across the globe. Forces like wind and gravity cause Earth's oceans to deflect either left or right across the globe, which results in currents, gyres, and eddies. Warm water is carried by currents to the poles where it becomes cooler. The cooler water has a higher density and more salt, causing it to sink deeper into the ocean. The warm water is lighter and less salty, so it floats on top. This is why it's also called thermohaline circulation, since it's mainly affected by heat and salinity. The cooler, heavier water gradually gets taken back to the equator, where this process repeats. Ocean circulation is significant because it affects literally everything on Earth. For example, slower ocean circulation causes the horizontal layers in the ocean to become more defined than usual. This is called stratification, which isn't good because the ocean's ability to mix waters of different densities is greatly reduced. Slower circulation also means altered salinity, which affects pH, which is very important to a marine organism. The ocean circulation has very direct effects on terrestrial life as well. The ocean absorbs the majority of the sun's heat, especially around the equator, and the ocean helps distribute heat and humidity across the globe with stored heat and evaporation. By doing this, the ocean circulation affects climate and temperature, as well as rainfall and storm paths. And because these currents affect all marine life, ocean circulation affects the fish markets on the coast as well. Why is this important? Because it's happening right now in the Atlantic Ocean. The Atlantic Meridional Overturning Circulation, or the AMOC, is circulating at a drastically lower speed than it should be. Along with everything you just learned, the slower currents are also expected to cause hotter summers and colder winters, especially on the East Coast. The Gulf Stream current also plays a big role in this, specifically regarding the US and Mexico, since the Gulf Stream current feeds into the AMOC, meaning effects will be more drastic on these coasts. So why is this happening? We already know it's because of heat and salinity changes, but what specifically is causing those? The short answer is climate change. The long answer is that extremely high levels of carbon dioxide in the atmosphere are causing many parts of the Earth to heat up. In the last 100 years, the ocean has increased in temperature by about 0.6 degrees Celsius, or 33.08 degrees Fahrenheit. Considering how large the ocean is, this is a very substantial amount. The ocean is also becoming less salty due to the melting of glaciers and ice sheets. These frozen structures are made solely of fresh water, so their melting dilutes the ocean's salt water. So to recap, the ocean is getting hotter and less salty, which means less dense water and slowed ocean circulation. Needless to say, all of this that's happening is very bad and will likely get worse. But is there anything we can do to stop this from happening? Not exactly. Even if we stopped emitting CO2 right now, there's already such a high amount of it in the atmosphere, so ice caps will continue to melt for a very long time and ocean circulation would not show improvement. That's not to say we shouldn't try to prevent climate change from getting worse, because it can and will if we don't, but even our greatest efforts at this point won't get us back to normal. So now you know what ocean circulation is, how it works, and why it is so important.